This video will clearly explain the concept of qubits, the fundamental building blocks of quantum computing. The quantum bit, or qubit, is the fundamental unit of quantum information. Unlike a classical bit that is either 0 or 1, a qubit uses superposition to exist in both states simultaneously. Mathematically, a qubit state is represented using Dirac notation as a vector in a 2D complex Hilbert space, psi equals alpha 0 plus beta 1 close angle bracket. When measured, it collapses to 0 close angle bracket with probability alpha squared or 1 close angle bracket with probability beta squared. The computational basis states are ket 0, representing the ground state 0 close angle bracket, and ket 1, representing the excited state 1 close angle bracket. The symbol psi close angle bracket is called a ket and means a quantum state. The Bloch sphere visualizes a qubit state. The north pole is 0 close angle bracket. The south pole is 1 close angle bracket, and the equator represents equal superpositions. Coordinates theta and phi define the exact position of the quantum state. Qubits matter due to exponential scaling. N qubits can represent 2 to the n states simultaneously. The relative phase allows quantum algorithms to use interference to find answers faster. However, noise causes decoherence, making quantum error correction vital for real-world hardware.